This video has some applications of the side splitter theorem. We are addressing one CCRSM standard, but we're not proving these theorems, we are applying them to find missing side lengths. Let's get started. The side splitter theorem is a line segment splits two sides of a triangle proportionally if and only if it is parallel to the third side. And that is proved in another one of my videos. In this video, we're focusing on applying the triangle side splitter theorem. So, will you go ahead and draw this picture with me? So, this is a triangle, okay? And I will draw this line to be parallel to this side. Okay, and it's easier to look at this if we're looking at some actual numbers instead of just looking at upper left and lower left and those kinds of things. So if this length was 4 and this length is 2, for example, and this length is 6 and this length is 3, okay, then the true side splitter theorem says that if the lines are parallel, then it'll divide the sides of a triangle proportionally. And we can look at that using proportions, as in the upper left side in my picture is 4, the lower left side is 2, and the upper right side is 6, and the lower right side is 3. Okay, so those are proportional to each other because those fractions are equal. Okay, now, although it's not exactly the side splitter theorem, we can also pull into this kind of this total left side is 6, and this total, the whole right side is 9, and look at those in our proportions as well. So for example, the upper left side is 4, over the whole left side is 6, and the upper right side is 6, over the whole right side is 9, and those are still proportional to each other. Okay, and also lower left side is 2, and the whole left side is 6, and that still is equal to the lower right side is 3, and the whole right side is 9. Okay, the thing to be super aware of and super careful with is that you are matching the same ratio on both sides. Okay, you can't kind of have it be upper left and lower left, and then upper right and the whole right. Like, it has to be the same ratio on both sides for it to be proportional. So let's look at a few examples where we're using the proportionality to find a missing segment. In example 1, we are given that XY is parallel to AC. And that's really important because without knowing that those are parallel, we can't use the side splitter theorem. So that's important that we are given that. They tell us that BX is 4 and that BA, this whole length right here, is 5. And they give us that BY is 6, and they ask us what BC is. Okay, so it looks like they're giving us kind of a whole left, so this is the upper left over whole left is equal to upper right over whole right. And they're giving us all of those numbers. So plugging things in, the ratio of 4 to 5, this upper left to the whole left, is equal to the upper right 6 divided by the whole right x. Now, once we have a proportion, most students are comfortable solving that proportion, and the most common method I've seen is by cross multiplying. 4 times x is 4x. 5 times 6 is 30, okay? And I keep my equal sign. That's the most common thing I see. Mistake that I see is missing the equal sign. So I keep my equal sign because it's equal. And then I solve this equation by dividing both sides by 4 to get x by itself. And I get 7.5 is the length of BC. In number 2, I will encourage you to pause the video and try number 2 and then see how I do on it. You can go ahead and pause the video. Okay, in number 2, we're given that XY is parallel to AC. And that's really important so that we know that we can use the side splitter theorem. Okay, they give us that BX is 9 and that BA, this full length right here, is 15. They give us that BY is 15, and they ask us what YC is. Now notice that we're not finding the whole length. It does not correspond with 15. It's the bottom, the lower right, that we're asked to find. So there's a couple ways to do this, and I think the easiest way is to figure out what this length is going to be equal to, what XA is equal to. And I can find that because I know 15 is the whole left. So 15 minus 9 is 6. So this length right here is 6. And I can use the true side splitter theorem that if the lines are parallel, then the sides are divided proportionally, and look at a upper left over lower left is equal to upper right over lower right. And look at 9 over 6 is equal to 15 over x. Okay, almost like I could just put a fraction equals fraction, and like that'll be your proportion that you're looking at. Okay, and once we have a proportion, we can solve it by cross multiplying. 9 times x is 9x. 15 times 6 is 90. And then to solve this, we'll divide both sides by 9 to get x by itself. And I know that x equals 10. This video was about the applications of the side splitter theorem. Thank you so much for watching.